Okay, the focus of this video is going to be on drawing Lewis structures. I have 3 examples here which I'll go through, and I'll use the rules and outline the rules for this first one, and we'll use the same rules for the second and third. So whenever you're drawing Lewis structures, you use the group number to figure out the number of valence electrons. So nitrogen is in group 5, and iodine is in group 7, and there's 3 of iodines. So we have 21 plus 5, or 26 valence electrons. Now, after we figure out the number of valence electrons, we pick a central atom, which in this case, it's written first, nitrogen, and we use a single bond to connect all of the terminal atoms. We want to always be keeping track of the electrons we're using, so we used up 6 to make each one of these bonds, because each bond is worth 2 electrons. So we have 20 electrons left. The next rule when you're drawing Lewis structures is to fill in the octets of the terminal atoms. So 1, 2, 3, 4, 5, 6. 6 and 6 is 12. 18. So I've used up 18 electrons. I still have 2 left, and that's a good thing because my central atom doesn't have an octet. Leftover electrons go on the central atom, and I have to use them all, and I'm out of electrons. And this is the correct Lewis structure for nitrogen triiodide. Every atom has an octet, and so that's complete. In our second example, we have hydrogen, which is in group 1. We have carbon in group 4, and nitrogen again in group 5. We have 10 valence electrons. We have to pick a central atom, and remember, one of the rules is hydrogen is never a central atom. So we'll pick carbon, and we'll connect all the atoms with a single bond. That uses up 4 electrons, so we have 6 left. This is where we have to be careful and follow our rules. The next step is to fill in the octet of the terminal atoms. Might not feel right, but that's the right thing to do. We're out of electrons, but we know our central atom doesn't have an octet yet, so what we're going to do is bring in electrons from the terminal atoms until that has an octet. The reason I brought 2 sets in is because it only has 4 electrons around it, that carbon. It needs 5, 6, 7, 8. So my final structure will have a triple bond between the carbon and the nitrogen. You'll notice hydrogen has its single bond, that's all it ever needs. Carbon has access to 1, 2, 3, 4, 5, 6, 7, 8, and that nitrogen has 8 electrons as well. Our last example really tests whether or not you use the rules correctly. So I have 5 electrons plus 6 times 2, and then I have to add 1 more because of that -1 charge. So 5, 17, 18 electrons. Now, central atom is written first, the nitrogen, a single bond to connect all the atoms. That uses up 4. So I have 14 electrons left. Our next rule is to fill in the octet of the terminal atoms. That used up 6, 12. Leftover electrons go on the central atom, in this case is the nitrogen. If I count and look at whether or not all these atoms have an octet, the oxygens have them, but the nitrogen doesn't. So I have to make a decision. One of these 2 oxygens has to share one of its lone pairs, so I'll bring it in here. And this is the correct Lewis structure for this nitrite ion. Because it's a polyatomic ion, I'm going to put a bracket around it and put a -1. So if you follow the rules, count up your number of valence electrons, pick a central atom and connect the other atoms with single bonds, fill in the terminal atoms until they have octets, and then leftover electrons go on the central atom. If you run out of electrons for that central atom, you need to share the terminal atom electrons to make sure every atom has an octet.